All right, everybody, let's get started. My name is Suresh Srinivasan. I'm the coordinator for the Minnesota Astronomical Society's beginner observing group or beginner group. It's also known as the BSIG. Today, we've got a presentation by Dave Falkner, who I consider to be a man of many hats. He's a visual observer who's somewhat dabbled with imaging a little bit. He's also a NASA ambassador for our club, one of our main liaisons with NASA. And I most recently found out he's also I'm going to pronounce this, hopefully I do it right, the ACEAP ambassador, which
That's right.
Dave's going to talk about a little bit today. So Dave actually just did a tour of some major observatories in Chile as part of this ACEAP program. And that's what today's presentation is about. So anyway, Dave, take it away.
Thank you very much, Ashesh. Hello, everybody. Welcome. Good afternoon. I'm going to be full disclosure. I am recovering from COVID, so I might have to stop periodically to clear my throat. But other than that, I'm feeling pretty good. So we're going to power through this. ACEAP, my amazing and unexpected journey to visit the research telescopes. And it's actually ACEAP 2020 because this trip was one that was originally planned right before COVID and then was delayed. So we'll talk about that in just a minute.
Hey, Dave,
ACEAP,
let me cut in just for 1 second. Hey, while Dave's doing his presentation, if people mind, if they have questions, if you go to the bottom of your screen, there's a little chat box on there. If you click on that, if you don't mind dropping your questions into the chat, and then when Dave comes up, pauses or changes topics, I'll then cut in and ask the question for you so that it keeps Dave's presentation moving along.
Yeah, I appreciate that. Yep. And I will pause periodically. So, all right. So ACEAP stands for Astronomy in Chile Educator Ambassadors Program. It was set up a few years ago by the National Science Foundation and a couple other organizations I'm going to talk about in a minute to raise awareness about the U.S. astronomical research being done in Chile. And it has two main goals. The first goal is to take people who are really passionate about astronomy and are involved in either formal or informal education about astronomy and provides them the opportunity to go down to Chile and tour these astronomy facilities, see the nature of the work being done there, get unprecedented access to the facilities and how they can access and use the data being collected and other resources from these observatories. And then the second goal is for them to come back and to talk to the public or other groups like students, K through college, about their experience in Chile, and just let people know, hey, we have these observatories down there, because there's a lot of people who don't even know we have observatories down in Chile, and even if they know we have observatories, they don't know much about them. So that's we're here to kind of spread the word. There's a lot of acronyms in here. Don't worry, I'm going to explain all of them, so don't worry about that. I first heard about this in 2015 when a woman came and spoke to us at the Minnesota Astronomical Society, and I was so fascinated by this. I'd been to Mount Lemmon, I'd been to Kitt Peak, and I loved visiting those observatories. And so I thought, wow, this would be really cool if I could do this. Not only would I be able to see these amazing observatories, but it knocks a couple things off my bucket list. Going down and seeing a country south of the equator, I've never done that. Seeing the southern skies, things like that. So they take applications in the fall. So I started my applications in 2016, and they take about 10 candidates each year. So I was never selected, and it kind of went through, and I went 2016, 2017, 2018, 2019, never selected. And then, of course, 2020, the people who applied in 2019 and 2020, COVID hit. And so that was kind of went by the wayside. And so I didn't really think much about it. A couple of years went by and didn't hear anything. The gentleman who runs the program, his name is Tim Spuck, and I would get an email from him every year inviting me to reapply again. I kind of took the astronaut view of this. A lot of astronauts have to apply many times before they actually get selected for the program, and that's kind of the way I took it. But then I'll never forget, as July 1st, 2022, it was a Friday. I was just finishing up work for the day, decided to check my personal email, and in my personal email was another email from Tim Spuck. I thought, oh, I got the program going again, so I probably inviting me to reapply one more time. But no, what he said was that, he realized this is coming out of the blue and that it's short notice. But the 2020 cohort wasn't able to make the trip for 2 years because of COVID, and they were now going to be going in on July 22nd of 2022, and they had a person who dropped out, and I was the first alternate. And if I was willing and able, then I would be able to go on this trip. And so I had to respond back to him by Sunday. Well, I almost fell out of my chair. I couldn't believe I was selected for this trip. And so I was back to him within 2 hours to let him know that, yes, I do definitely want to go. And then I had 21 days to gather all my stuff together and make sure my passport was in order and all of that. And I did. And then about a week before the trip, now remember, July down there is winter. Okay. And a week before the trip, they had a snowstorm on the mountaintop that dumped 1.8 meters of snow. This was a freak snowstorm. 1.8 meters is about 70 inches. That's 70 inches of snow. Completely shut down the observatories on the mountaintop. People were evacuated out. Needless to say, if we went down there a week later, we would not have access to the major telescopes on these mountaintops, which kind of defeated the whole idea of the trip. So we as a group decided to postpone this. And we postponed it to December. And so the new trip was from December 9th to the 19th, which wasn't a huge deal for me. I mean, it was a couple of months, but remember, some of these people have been waiting for 2 years to go. So it was kind of a big deal for them. But we all got down there and started our trip on December the 9th. The 10 people who went are listed here. I put this up just to show that, they're from all over the country. All walks of life. All of them are passionate about astronomy. Some do outreach, as a amateur astronomer. Some are actually involved in teaching astronomy or are planetarium coordinators. And then the person in the bottom there, Catalina, she was kind of a late arrival on this trip, but she was a graduate student from Chile. Who spoke English and Chilean, which is very nice because we needed a translator. So that she worked out very well for the trip. I want to talk about why Chile. Why is Chile such a hotbed for astronomy? As you can see, it's a very long country. It's about 2,600 miles long, but only a couple hundred miles wide. But the northern part of Chile is a desert area. It's very dry. And it's kind of sandwiched between the Pacific Ocean and the Andes Mountains, and that makes that air mass above the desert there very, very stable. And so it's dry, it's stable air, a lot of mountains in there, so that you can put observatories on tops of the mountains. And it's also, when I say a stable air mass, it only gets about 0.2 inches of precipitation annually, which is why that snowstorm was such a freaky snowstorm. And as a result, you have well over 300 nights of clear skies every year. So as a result, it's very, very astronomy friendly area. And then there's a stable government there, and the politics are good. The people are very, they've really embraced astronomy. In fact, they have a whole astrotourism economy down there, along with the telescopes. And of course, a lot of the Chilean people work at the various observatories that are down there. It's estimated that about 70% of the world's astronomy infrastructure is located in Chile now. Everything's metrics down there. So since a lot of you may not be accustomed to metrics, I just wanted to review that a meter is 39.37 inches, or a little over 3 feet. And we describe telescopes by the size of their main mirror, which is measured in meters. So of course, when we talk about a 1 meter telescope, we're talking about a 40-inch telescope. And then a kilometer is 0.62 miles. The other thing that's measured in meters is altitude. So these observatories are typically about 2,300 meters, 2,700 meters, and now, that's about 7,500 or 8,000 feet. I may throw in the feet in there too, just to let you know. But yeah, everything's in meters or metric. I'm gonna I'm going to focus the presentation on the observatories, but I do have a little bit at the end that can talk about other activities if we have time. But as ambassadors, we not only visited the observatories, but we were also given the opportunity to experience the culture, the food, and the hospitality of the Chilean people. So it was really a well-rounded trip, and so we were able to do both. And you can see that some of the activities we did some sightseeing in Santiago. We visited a tourist observatory, we visited a nature preserve, and a flamingo national park, which was absolutely phenomenal. So I just wanted to throw that in there. Well, first of all, let's talk about the observatories. And so we landed in Santiago. Most of us landed in the morning on December the 9th. We took red eyes from the United States down there. And so the first day was kind of an arrival day, and you could do what you wanted to. We did a little bit of sightseeing. That night, we had kind of an impromptu dinner where we got the people together. We have all but two people here. One of them had a delay in his flight out of Houston, didn't get there till later in the evening. And then Catalina, the Chilean graduate student, joined us the next day. Tim Spuck is the person on the far left here, the glasses on his head, and he was kind of the leader of the group. And that's the rest of the group with myself included. The first day was an orientation day, and we went to an office of the AUI in Santiago, and we learned about the organizations that sponsored this trip and some safety, some rules and regulations, stuff like that we needed to know. We also had presentations by two women who talked about the outreach that's being done, particularly for women and in colleges, helping them to choose STEM careers, science, technology, engineering, and math careers, which is not a path that a lot of women take down there. In fact, we all know that women in STEM careers is unfortunately pretty rare. So they really like to cultivate that relationship and to mentor the women and encourage them to get into STEM careers. So I mentioned these organizations, and these are the organizations that sponsor the ACEAP program and also help to run the facilities that the United States has down there. So the national facilities, if you would. One is the Associated Universities Incorporated, which is pretty much what it sounds like. It's a whole group of universities that have come together as a nonprofit organization that and the AUI is primarily responsible for the administrative piece of it, the contracts, the human resources, payroll, things of that sort. The Association for Universities for Research in Astronomy is another organization that, and their part is more involved in the operations of the facilities. So they are in charge of the residence halls, the cafeterias, the transportation, maintenance of the buildings, things of that sort. And then the National Science Foundation is kind of the umbrella organization over all of that, and helps to fund all of these organizations. Tim Spuck, who was in charge of our group, was actually part of AUI. So. Then that night, we had our official beginning dinner kickoff for the whole expedition. Everybody was there at that point. So this is Catalina, and this is Alan Strauss, who was missing from the last picture. And here's here are the women we talked to, who talked to us about the outreach and the like. So I got to tell you, Chilean food is fabulous. Of course, with all the coastline they have, the fish was wonderful, and the Chilean wine is excellent. So we had a lot of great food down there. The next day, we flew to La Serena. La Serena is a coastal town, kind of a resort town, and was where we got together, and we actually were. Let me mute that. So we were in a hotel right across the street from the ocean, and it was very nice. You can see that was from my hotel room, so it was a pretty nice place. And we spent the afternoon there, kind of doing a little bit of sightseeing. Went to a restaurant, got some great food, and that evening we did go to a tourist observatory, which I'll talk about later if we have time. And then the next day we took what I call an airport shuttle. I'll call it a bus, but it was an airport shuttle, and that took us up to the Noir Lab Observatory. So took the road along here. At this point, we turned off onto a dirt road that was pretty much controlled by the Noir Labs. It was a private road that took us up to the two observatories here. Noir Lab is the National Optical and Infrared Laboratories. They are the U.S. National Center for Ground-Based Nighttime Optical Astronomy. The forerunner of those was NOAA. It was NOAO, which some of you may be familiar with, which is the National Optical Astronomy Observatory, and that's what Noir Lab became. Okay, and they run specifically the Kitt Peak National Observatory, the Cerro Tololo Observatory, which we're going to go to next, and then the Vera C. Rubin and the Gemini North and South observatories, as well as the Community Science and Data Center, where people can go to get all of the data that is collected by these observatories. Okay, before we go into Cerro Pachón, any questions at this point?
I don't see anything on the chat. Does anybody have any questions for Dave?
Okay. Suresh, are we good to go?
All yours.
Didn't hear you.
Go for it. Can you not hear me?
Okay, I'll assume so. The first place we went to was Cerro Pachón. Cerro means mount, if you would, so Mount Pachón. And there were 3 observatories at Cerro Pachón. The one on the left is called the SOAR Observatory. The one in the middle is the Vera Rubin Observatory, and the one on the right is the Gemini South Observatory. All 3 of these are located at about an altitude of 2,700 meters. It's roughly 8,000 feet. So we kind of drove up here, and then they're all located along a ridge here. This is the SOAR telescope, the Gemini telescope, and the Vera Rubin telescope there. You can kind of see they're all kind of along the ridge there, the high altitude, beautiful scenery, of course. And the first one we visited was the Gemini South telescope. It's a twin to the Gemini North telescope. They kind of work in concert with each other. It's a Cassegrain telescope, and for those of you who may not be familiar with that, I'll explain that in a minute. It has an 8.1 meter mirror, f1.8, which just means it's fairly short for the size mirror that it is. It has a 1 meter secondary mirror, and it uses what's called adaptive optics, and I'll explain that in a minute too. And it is the most infrared optimized ground-based telescopes in the world. So a Cassegrain telescope, just real quick review, light comes into the main mirror back here. It reflects back to a secondary mirror, which then reflects light back through the center here, and the instrumentation can be located back here. Typically, it's cameras and spectrometers. You can, if the telescope allows, you can also position an instrument here like a camera. Well, this is called the prime focus, and we'll see that there's a few telescopes that we visit that do have equipment at the prime focus as well. This is the Gemini control room. Doesn't look like a whole lot, but it's computers and monitors where they can monitor not only the weather and the telescope and control the telescope from here. They can control either Gemini North or Gemini South from this control room, and likewise from Gemini North they can control either telescope as well. So that was complete control of either or both telescopes. As you can see, they have the time up here both in Chile and in Hawaii. And we talked to the guys who worked on this, and they basically, set it up to do the nightly run. They have a whole schedule of where they need to be at what time, and run the telescope from here. That is the Gemini South telescope. It was pretty cool to be up close and personal to it, to say the least. The mirror is 8.1 meters, but I don't know if you can notice or not, but they kind of mask off the outer half meter, and that's to keep any kind of spurious light from the edge of the mirror from coming through. It's an alt azimuth mount. So this table's whole floor here moves to move the azimuth, and then there's a huge shaft here that the telescope pivots on. The equipment is located underneath the mirror. This is the equipment underneath the mirror here, and there's a few things there. One is a planet imager that's capable of directly imaging planets around nearby stars that are 1/1,000,000th as bright as their host star. It also has a near infrared camera and spectrographs, and the Gemini multi-object spectrographs. And I'll explain spectrographs in a minute. And all the acquisition and guidance equipment is located there as well. Because of the location of the instruments, you can switch from one instrument to another in just a matter of minutes. They just rotate a mirror down there to do that. And they routinely each night will use several different instruments. When you talk about light or electromagnetic radiation, we typically think about visible light here, which is what all of us amateur astronomers look at. And then you go into the infrared here, and then eventually down into radio waves and microwaves. So most of the telescopes that we will look at, concentrate, mainly in this visible light, and then including the Gemini may go a little bit into the infrared. Of course, the Webb telescope is more, the near to mid infrared frequencies, and then later on we're going to go to an observatory that deals with microwaves into the radio frequencies. But I just want to kind of give you an idea of what we're talking about there. As you can see, we got up to right next to the mirror. I could just damn near touch it if I wanted to. It was pretty impressive. And then right next to it, this is part of the bearing, the altitude bearing, and the shaft comes through and into the bearing, and they actually pump oil in, and there's about 15.6 nanometers of oil that separate the shaft from the bearing, making it almost frictionless. And so if they disconnected all of the drive units, you could actually maneuver this entire telescope easily with a couple of fingers, because it was so well balanced and they're so frictionless. It was pretty impressive. Down below the telescope in the basement, if you would, is the recoating chamber, and they recoat the mirror about every 5 years. They have to remove the mirror and lower it down through the floor into this recoating chamber. It's kind of like a giant vacuum chamber, and then they recoat it. Now, to make the Gemini optimal at the visible and near infrared, they actually coat it in silver. So for visible frequencies, aluminum is an excellent reflector. And then, but when you get to the infrared, it turns out that silver is a better reflector when you get into the near infrared. And then when you go from the near to the mid infrared, gold is actually a better reflector, which is why the James Webb has gold coating to it. But the problem, there are two main problems with silver. One is that it tends to tarnish. Okay, and the other is that it doesn't adhere to glass very well. So when they do coat it, they do these layers. So the substrate's glass, then they put a thin layer of nickel chromium on there, then the layer of silver, another layer of nickel chromium, and finally a silicon layer to protect the whole thing to keep it from tarnishing. So and then between the 5 years they do clean the mirror periodically. And there's a couple of different methods they can use for cleaning the mirror. This is the pier of the telescope, and all those flags are the countries that help make the Gemini telescope possible and use the Gemini telescope. That's starting from left to right. That's South Korea, Argentina, United States, Brazil, Canada, and right around the corner here is the Chilean flag. Chile, because they provide the land for all the telescopes, they automatically will get 10% time on those telescopes just because they have the land for that.
Dave, can you hear me?
Okay.
Dave,
so this is a picture that Noir Lab provided. We can see where the vents are open now for the evening, and to keep the telescope at ambient temperature. It turns out a lot of these large telescopes are air conditioned during the day, and they're air conditioned to a specific temperature. They're air conditioned to the temperature that it's expected to be at 9 p.m. that night, so that when they open up the observatory, it will automatically be at ambient temperature. There's no cool down period, so to speak. And then that yellow light coming out of there is part of the adaptive optics piece. And so let's talk a little bit about adaptive optics. So the atmosphere, even up at these altitudes, the atmosphere can distort starlight as it comes through. So what they do is they have a beam splitter, and they take a portion of the light that comes off of the mirror, run it through a computer and a controller, and then there are actuators on the back of the mirror that actually distort the mirror to counteract the effect of the disturbance, the atmospheric disturbance, so that you get a nice corrected wave in, and it makes an amazing difference. So here's without adaptive optics, and with adaptive optics, you can see how much clearer it is. Same thing here. This is without, and this is with, and it will actually make it quite clear. And then let me go through this slide here, and then I'll stop for questions here. So this is one of the things that the Gemini South was able to do, and it captured the sharpest image ever of the universe's most massive star. This is star R136A1. It's not the largest star, but it is the most massive. Okay, it's in the Large Magellanic Cloud, and it's 170 to 230 times the mass of the sun. It was captured using a couple of imaging equipment, one called Zorro, which is a fast, low noise camera. Zorro means fox in Spanish. And then the DSSI, which is a differential spectral survey instrument, which is another wide field diffraction limiting imager. And by using the adaptive optics and these cameras, they were able to get an image that's actually slightly sharper than James Webb Space Telescope and 3 times sharper than the Hubble Space Telescope, all with a ground-based telescope. The star that they captured is 35 times bigger than our sun. It's about 9 million times more luminous, and the surface temperature is about 10 times hotter than the sun. For you astro imaging geeks, the resolution here is about 30 milliarc seconds. The exposure time was 60 milliseconds, and they took 40,000 images over 40 minutes. Okay, I'm going to stop there.
Dave, can you hear me?
Suresh, is there? It looks like there's some things in the chat.
Dave, can you hear me? Dave, I'm waving at you. Can you hear me?
Can you hear me?
I can hear you. You can't hear me.
Oh, all right.
I'm waving at you.
Well, let me check the chat myself. How about that? Okay. I can hear David Schresh. Well, how do they clean the mirror? There's a couple of different ways they do it. One is with carbon dioxide frost. So they take these hoses and they spray carbon dioxide frost on there. And of course, carbon dioxide it's like dry ice, and the frost when it hits the surface of the mirror will almost immediately evaporate. But when it does that, it hits the mirror long enough to capture the dust particles and takes the dust particles with it when it evaporates. And that's one of the ways they can clear it. They can do the mirror. The other is that they use what's called a horse soap, and they actually use like these special sponges and a horse soap to wipe the mirror and clean it off. And it to me it looks like you'd scratch it, but apparently it's non-abrasive at all, and it works quite well. So you can read about it online. Okay. Suresh, I don't know why I can't hear you. I don't know if we rent. They're not U.S. territory. Okay, they're definitely Chilean, and I don't know whether we rent the space or if Chile gives us the space for the time on the telescopes. I'm not real sure about that, but we do have some arrangement with Chile on those.
Dave, do another check. Can you hear me?
Yeah, I can hear you. I can hear you now.
Ah, there you go. There you go. Yeah, for whatever reason, you couldn't hear me for a few minutes.
Yeah, I think maybe
So,
my volume was turned down. So
so there was
okay.
another question in here. Above that question about cleaning the mirror, are these sites considered to be U.S. territory, or does the U.S. just have a presence?
No, it's they're not U.S. territory, and I'm not sure whether we rent them from Chile or whether we just have an agreement with Chile, because Chile does get 10% of the time on all the telescopes. So that may be the trade-off there. Okay.
I think we're caught up on the questions. Go for it.
All right. Let me do that. All right. Oh, down here. There we go. All right. The next telescope we're going to look at is the SOAR telescope, which stands for the Southern Astrophysical Research Telescope. These are the 4 entities that are in charge of that telescope. This telescope is a 4.1 meter Cassegrain telescope. It has a fiberglass dome, and it also has adaptive optics. This is a shot of it. Those triangle pieces are the mirror cover. So they opened up the mirror cover for us to take a look at it. And then all of the equipment is, the equipment in this case is not attached to the telescope itself. It's actually off to the side of the telescope over here. So what they do is they bring the light in, and then there's another mirror that shines the light through the center of the main shaft over to the equipment, and they can capture the light over here, and there's a mirror over there, and they can change from one piece of equipment to another in just 60 seconds. Here you can see the actuators at the bottom for the mirror. And this large piece right here is not attached to the telescope. It's actually sitting below the telescope, and it's called the Goodman High Throughput Spectrograph. And it's actually fed, the light is fed into that through this huge fiber optic cable that kind of snakes around here and comes up to here. And it's called the Python. So it's a huge fiber optic cable that routes it in there. And it's a spectrograph, high resolution spectrograph. And now we talked about spectrographs, and for spectroscopy, so you're going to see that a lot of these telescopes have spectrographs, and spectrographs are used for two main things. One is that when you spread out white light, you get all the colors of the rainbow. But when you pass light like that through a gas or through another element, that element will have specific lines at specific frequencies. Whether they absorb it from light from behind it or whether they give it off, it will be at the same frequencies. So astronomers can determine what elements are in an atmosphere or whatever just by the lines that show up, and they can figure out what the composition of that object is in terms of elements. The other thing they can do is these spectral lines will shift. It's a Doppler effect, so they'll shift toward the red if the object's going away from us. They'll shift to the blue if the object's coming toward us. And so we can also tell if an object is moving away from us or toward us. And even for an object like a star, for instance, we can actually detect the rotation of the star, because one side's moving away from us, one side's moving toward us, so they can actually detect that with these spectrographs. This is an image that was taken by the SOAR telescope. If you recall, I think it was last summer, NASA took a spacecraft and they wanted to see if they could alter the trajectory of an asteroid, kind of one of these Earth defense systems, if you would. And they chose a double asteroid that was out in space, and they crashed the spacecraft into one of the asteroids to see if they could change the orbit of that asteroid around the other asteroid. It was called the Double Asteroid Redirection Test, or DART. Okay, and 2 days after DART slammed into the asteroid, SOAR took this image, and this is the dust trail that came off from that spacecraft hitting the asteroid, and it's about 10,000 kilometers long, and DART was able to image that, which I thought was pretty cool. So Let me cover Vera Rubin, then I'll stop again. Vera Rubin, the Vera C. Rubin Observatory was formerly known as the Large Synoptic Survey Telescope, which you may have heard of, but now it's been renamed. It is now the Simone Survey Telescope in the Vera Rubin Observatory. It is an 8.4 meter mirror, but it's still under construction, as you can see. We almost got in to see the observatory being constructed, the actual observatory itself, but unfortunately we lacked steel-toed shoes, and so as a result, because of safety reasons, we weren't allowed in there. This will be an 8.4 meter mirror with f ratio of 1.23, a 3.2 megapixel camera, which I'll talk about in a minute. It's designed to take an image, a 15-second image every 20 seconds. So it takes a 15-second image, and then in 5 seconds, we'll move to the next part of the sky and settle, and then take another 15-second image. The camera, for you astro imaging geeks, has a 3.5 degree field of view, and the camera is roughly the size of a small car, weighs about 6,200 pounds, and is a 3.2 megapixel camera. Let me go next. So we were able to get into the control room. So this is the control room for the Vera Rubin telescope. It will image the entire southern sky every week. So this will also be able to monitor the weather, the progress on taking the images, and if they decide to do some other science, of course, they can do that as well.
Dave, can I
Yep.
chime in here for a second?
Yep.
So Kevin asked, can you give us an idea of the elevation that you're at when you're visiting these sites, the temperature and the wind?
This elevation is about 8,000 feet. The temperature wasn't bad. It was, I'm going to talk about this in a little bit. The temperature itself was probably around low 80s. It wasn't really hot. There was some wind during the day, but it usually dropped off at night. Once the sun went down, as often happens.
80s?
Yeah.
Did you say low 80s?
Low 80s
in the
yeah.
winter? Wow.
No. This is summer.
Oh, summer. Okay.
Yeah, we're down. We're down. It's December, so it's summer for them.
Summer down there. Got it.
Yeah.
Kevin Pierce asked, was there some kind of explosive on the DART craft that crashed into the asteroid to change the trajectory? If not, what was the size of the asteroid?
It was just the spacecraft itself slamming into, basically a suicide run, just slamming into the asteroid. I don't know the size of the asteroid. You'll have to look that up. It wasn't huge, but it wasn't small either. So they wanted to it was large enough that they could track it, and they could track the orbit of it around the other asteroid to be able to determine how much the orbit was changed by the spacecraft going in there. I don't know the specifics on the size of the asteroid though.
And it wasn't the main asteroid, it was the moon of the asteroid, right?
It was the smaller of the two asteroids, yeah. Right. I guess you could call it a moon, like, Charon is the moon of Pluto, right? So
right.
A lot of people consider that almost like a double, they don't orbit around, Charon doesn't orbit around Pluto. They actually orbit around a common center of gravity between the two, right? So
160 meters is what I just looked it up for Kevin. It's 160 meter wide, moonlit.
Yep. Okay. So next to the Vera Rubin Observatory was another observatory. It's a 1.2 meter telescope in there, and it's called the Vera Rubin Auxiliary Telescope. Essentially, it's the finder scope for the Vera Rubin, it supports the observatory with star spectra, atmospheric measurements, and catalog corrections. And then this building here actually is holding the mirror right now. They don't have the mirror installed in the telescope as yet, so because they're still under construction. So the mirror is sitting in here right now. This is the mirror blank. This 8.4 meters. This is before it was coated and polished and all that. The science expectations for the Rubin Observatory: going to probe dark energy and dark matter, take an inventory of the solar system, explore the transient optical sky, and map the Milky Way. So it's pretty exciting to get that going. It's an amazing telescope, to say the least. Okay, and there's our group all set to go inside, but we couldn't go inside, so that's the way it goes. But it was pretty cool just to be even around it and to see the control room. Okay, from here we went over. So we're still in the afternoon. We got back in the van. The Cerro Tololo Observatory is only about 10 kilometers away, so we drove over there. And before I get started on that, are there any final questions about Cerro Pachón before I talk about Cerro Tololo?
I don't see any in the chat. Does anybody have any questions they'd like to ask? What kind of inventory?
Was that mirror made in the lab in Arizona? It looks like about the right size.
Yeah, I think it might have been. And just out of curiosity, can you see this when I'm holding this piece of glass?
Yes.
So this, when they make those mirrors at the Seward laboratory at the University of Arizona, the glass comes in chunks like this. And they inspect the glass, and if the lot looks good, then they put all these chunks of glass into the mold and basically melt it into the shape of the mirror. They turn the mold at a specific rate that will determine the curvature of the mirror as it melts, and then it cools, and then they're able to go and polish it and all that. This is a piece of glass that was actually rejected. So this lot of glass was rejected, and it was destined for a mirror being made for the giant Magellan telescope, mirror number 5. And so we had one of the guys was from University of Arizona. He did outreach down there, and including the lab, and so he brought everybody a chunk of glass from the rejected Magellan telescope, which I thought was kind of cool. Okay, so we can proceed. So the next stop is Cerro Tololo Inter-American Observatory. This is the oldest observatory down there for the United States. And there's over 40 telescopes, over 45 telescopes there. Everything you see in green is a telescope on this. The yellow buildings are the administrative, the dormitories, the dining facility, the offices, and then down here, these are the maintenance buildings down there. I'm not going to talk about every single telescope because there's over 45 telescopes, but I will highlight some of the more significant telescopes and groups of telescopes. We stayed in the residence halls for 2 nights and ate in the cafeteria. The summit on this one is about 7,500 feet, about 2,300 meters. We got there in the afternoon, we settled in, had supper, and then went to the mountaintop to observe sunset. I took a number of pictures, and although I saw the green flash, I didn't get a picture of the green flash, but that was pretty exciting. And then we kind of settled in here. So this is the group doing a little bit of fun stuff, spelling out ACEAP on the mountaintop there. And then we stayed to observe, and it was just amazing. These are the 2 largest telescopes on the mountaintop there, and I'll talk about both of those. The Victor Blanco is this one here, and this is the SMARTS 1.5 meter. This is a 4-meter telescope, 1.5 meter telescope. And then, of course, you can see the large and the small Magellanic clouds up in the sky. Very easy to see with naked eye. They did bring up a small. You don't look through these telescopes. None of these telescopes have eyepieces to them. They're all equipped with cameras and spectrographs, but they did bring up a C11 for us to look through at the Tarantula Nebula, Toucan 49, some of the other objects that the planets were out. But it was just amazing to observe the sky that night, and a little disorienting. From a guy from the Northern Hemisphere all my life, you go down to the Southern Hemisphere, and Orion's upside down, and Gemini's upside down, and all these constellations that I'm used to seeing are upside down. The sky moves from right to left, not from left to right. Moon phases are backward. It's a little disorienting at first, but you get used to it. But on the other hand, it was really cool to see some of the southern constellations that we never see from this north, this far north. The next day, we did the tour of CTIO. This is an aerial view of that from Google Maps. It looks flat. It is not. Trust me. It's like looking at the moon, the full moon. You don't see any relief. It is very hilly here. All the roads at the top of the observatory are paved to cut down on dust because they generally drive from one place to the other because that's how far. I mean, it's really hilly, and so a rule was when you were wandering around at night after observing, if you ran out of paved road, you've gone too far. So you need to turn around and go back. We had one guy who kind of wandered around for about an hour before somebody found him and got him back to the dormitory. So let's start by looking at the mountaintop. This is the very top of the mountain. And we'll zoom in on that. So you can see the number of telescopes up here. Here's a map of it. The Victor Blanco telescope, the SMARTS telescope, we'll talk about them in a minute, the Curtis Schmidt telescope, and the Chase telescope. There I am at the mountaintop. Again, out in the sun, it was a little bit warm, but not uncomfortably warm. I'm wearing long sleeves and long pants, not because of the temperature, but because of the UV index. In the summertime here in Minneapolis, UV index might, at max might hit around 6. On the mountaintops there, we were typically dealing with UV indexes around 8 to 10. So you really had to protect yourself, wear sunscreen, and wear lightweight long sleeves and pants to protect yourself from the UV. So that's, and a hat. Hat was very important. So right here we have the Victor Blanco, which is a 4-meter telescope, and a 1.5-meter telescope with the SMARTS telescope behind me. And we'll start with the Victor Blanco. The 4-meter Victor Blanco telescope, named in honor of Manuel Blanco, 4-meter Cassegrain, built in '74 at about the same time that the Mayall telescope was built at Kitt Peak. They're almost identical in their design and look and feel. When we got there, they were doing maintenance on the telescope itself, so we couldn't go into the observatory in the morning. We did get to see the control room here, which, as you can see, looks a little more antiquated than the control room for the other observatories we were at, but they do the job and they can control all the telescope movements from down here as well as from the observatory floor. And then they like the Mayall telescope, they had kind of an observing gallery. So there's windows over here where you can see the telescope. And then they had kind of a museum here. So this is all equipment that over the years was built for use on the telescope, many of which are like one of a kind. They're built specifically for that telescope. And there's cameras and spectrographs and the like there. In the afternoon, we were able to go back and they had finished their maintenance. We could actually go into to see the telescope. Here we have a white dot where they do some of their calibration, camera calibration, and this is the telescope. And I believe the camera, this is a camera instead of the secondary mirror up there. So we were able to see that. This is the recoding chamber for the 4-meter located on the floor there. As you can see, we got up close and personal with the computer, with the telescope. And then later that night, in the evening, right before sunset, we were invited to come in and we could be on the observatory floor when they actually opened up the observatory. There's only about 3 of us who took advantage of that, but I thought it was really cool. I want to show you this. This is speeded up about 3 times. Okay. So first they opened up the slit. Okay. And then they opened up the vents on the side there. You can see, obviously, this is the tallest thing on the mountain, so spectacular view. That large yellow structure there is the place where they store the mirror and or the camera, depending on which is not being used on the telescope when it's not in use. And you can see see that there's a little bit of piece here between here and here, the little track there. Okay, that's where we were standing when they began to move the telescope. The whole floor moves except for that area. And so So I kind of panned around just so you can see the view from up there. And then, so I'm standing still. The whole floor is moving at this point, and they're moving the telescope around to get into its position for the evening. And so the camera up here takes an image, and this is actually fiber optic cable that's being routed down, and the some of the equipment is actually underneath the telescope, and they route the image down to the equipment underneath the telescope. Okay. There are two main instruments that this telescope uses. One is called the Dark Energy Survey Camera. It's a 570 megapixel 3-degree field of view camera located at prime focus, right up here. And it was used to conduct a visible and near infrared survey of the sky aimed at probing the dynamics of the expansion of the universe. And then located below here, and that's where they routed these cables down to, but underneath here, you can't really see it because there's a cover, but the Cosmos Cerro Tololo Ohio State multi-object spectrograph is there. It's a high efficiency spectrograph capable of photographing spectrums of multiple objects simultaneously. So those were the two main instruments that were located on that. And this is an image here. So from 2018 to 2021, they did a survey of brighter galaxies, and they were trying to identify variable objects from time scales of hours to years. This is an image from that survey. It's of galaxy Centaurus A, and you can see that there's a lot of dust clouds there associated with that. It's about 12 million light years away. And the work that was done with the Victor Blanco telescope, particularly this work here, is a pathfinder to the new Vera Rubin telescope when it's made operational. So it'll build on the work that was done here. Okay, let me pause here real quick. Suresh, are there any questions?
Yeah, can you hear me? Dave, can you hear me? I don't think Dave can hear me again.
Okay, I can hear you.
Can you hear me, Dave?
Yep.
Okay, so there's like 4 or 5 questions. I think I missed one from earlier. Mary Ellen Inskeep asked, what kind of inventory of SS? I don't know what SS is referring to, but maybe you do. What kind of inventory of SS? Mary,
SS is solar system.
Oh, solar system. So now that we know that, say the question again.
What kind of inventory of solar system? I don't know.
Oh, asteroids, right? Asteroids, comet, any object in the solar system, any more moons that we have that we may discover, dwarf planets. At this point, mostly asteroids, probably. Okay.
Then Kevin Pierce asked, what reference, and I believe he means star, what reference to use for calibrating an alt-az telescope for them since Polaris is invisible? And then Kevin Nasel responded to that by saying Sigma Octans, which is the southern pole star, or the closest the pole star.
Yeah, that's a good question, and I honestly don't know. To be honest, I didn't ask that question. That's a good question. I don't know what they use.
Trina asked, did you meet any astronomers that were down there doing research?
You know, I didn't see any astronomers. We talked to a lot of the personnel who ran the telescopes, but we actually did meet one astronomer. There was a gal who gave a presentation in the afternoon at Cerro Tololo on some work that she was doing, and I'd have to look it up exactly. It had to do with galaxy and distance measuring with galaxies, and she was doing some work on that. But that was the only astronomer that we really ran into. Most of them were, see, a lot of these people are working remotely. They're not even on the mountaintop. So because the data goes to the data center. So there are very few astronomers that are actually on the mountaintop.
Kind of a related topic to that. Did you run it? Like, what kind of research were they doing at the time when you were there? I know you mentioned the one, the survey for 2018 to 21, but what are they doing now?
That's a good question. Well, actually, I'm going to talk about some of that stuff as we go on. Okay, so let's hold off on that.
And then the last question is Mary Helen asked another question. What is the scale of that whole site map? How many miles, kilometers that you?
Well,
that
it's not kilometers. It's I would say it's probably let's say half a kilometer around. So it's not huge, expansive, wide. You know, it's different levels really
maybe a couple city
telescopes.
blocks, maybe a couple city blocks.
Yeah, more than that. Probably, I'd say probably maybe a half mile square. Yeah.
Okay. Any other questions? That's all I have right here on the chat right now.
Okay. Let me go ahead and let's finish up Cerro Tololo and then we'll stop again. Okay. So we're going to move to the SMARTS consortium here. So SMART stands for Small and Moderate Aperture Research Telescope System. So in 2001, Noir Lab, actually NOAO, which is the predecessor to Noir Lab, decided that they were not going to support telescopes smaller than 2 meters. So it's going to be incumbent upon those universities and or countries that have telescopes up there to support their maintenance of their telescopes. They could contract with Noir Lab to do that, but Noir Lab would charge them, if you would, to do that. So so what you're going to start seeing here are a number of consortiums of telescopes that are under 2 meters in diameter, which is actually most of the telescopes on the mountaintop. So the first one is the SMARTS consortium, and they have four telescopes on the mountaintop. The 1.5 meter telescope that we'll see in just a minute. Then this telescope is a 1 meter telescope. This telescope is a 0.9 meter telescope. These two telescopes are not part of SMARTS. They're different telescopes. We'll talk about them in a minute. And then this one was down the hill a little bit from those. This is a 1.3 meter telescope. And so this consortium has members on it. The member institutions fund and manage these telescopes. The membership is open to individuals, institutions, and international partners, and members can buy time on the telescopes to use them. In return, Noir Lab maintains the telescopes, and they get 25% observing time. We only had access to the 1.5 meter telescope, but in fact, with most of the telescopes, particularly the telescopes that were not operated by Noir Lab, like the Victor Blanco telescope, most of the other telescopes were locked up. We didn't even have access to them. They're all run remotely. So this is the 1.5 meter telescope, the SMARTS telescope. Again, they opened up the cover for us, so we can see that. It only has one instrument, and it's located at prime focus up here. And again, it's a camera that takes the image and then routes it down via fiber optic to the processor down here. It's called Chiron, CHIRON, which is it's just a high resolution spectrograph designed to measure star rotation velocities. Okay, so that was that telescope. And then the SMARTS 1 meter and 0.9 meters are on the mountaintop. The 1 meter telescope used to be at Yale, and it was moved up there in '72. The 0.9 meter telescope is Bowler and Shivens Cassegrain, built in '65. Both of those just have an imaging camera on them. The other two telescopes, the 0.5 meter Chase and the 0.6 meter Curtis Schmidt, are not part of the SMARTS consortium. They're part of the Tenet telescopes, which I'll talk about in just a second. And speaking of the Tenet telescopes, these are most of the Tenet telescopes here. Aside from these other two that are up here, almost all of them are down here, including this one here and that one there. So let's talk about those. Okay. The one first we're going to talk about are the prompt telescopes. They consist of 6.4 meter telescopes here, all built by the University of North Carolina. Those are used to follow up on the afterglow of gamma ray bursts. So gamma ray burst is an astronomical phenomenon where a object out there gives off a massive burst of gamma rays, and that's detected by a different telescope. But when it's detected, they send out an alert. And when the alert's received by these telescopes, the afterglow doesn't last very long. And so they want to get telescopes on it right away. So they have these 6 telescopes that go onto it. And each of these telescopes has a different kind of filter in it. So that they're able to simultaneously image the afterglow in multiple wavelength observations and in with filters on them. So that's the main use of those. There's also a 0.4 meter telescope, excuse me, a 0.8 meter telescope, this one here. And when they're not being used for the gamma ray burst, they're used for undergraduate and high school education throughout the state of North Carolina. These are 5 telescopes that are part of the Las Cumbres Observatory Global Telescope Network. There's a total of 25 telescopes worldwide on this. These are 3 plane wave 1 meter telescopes here, and these are 2 basically Meade 16-inch Ritchie Creighton telescopes on roll-off roof observatories here. They're all equipped with cameras, CCD cameras, and are operated remotely. They're available to both scientists and education observers, used primarily for transient astronomical events ranging from seconds to years. They were locked up, we really couldn't see them. So then I mentioned the Curtis Schmidt telescope at the mountaintop was part of this group of telescopes. It's run by the University of Michigan and named after Heber Curtis, who was the director of University of Michigan Observatories from 1930 to 1942, and was also one of the debaters in the Great Debate of 1920 over the size of the universe. And then there's the Chase telescope, which is the Chilean Automatic Supernova Survey, which is exactly what it sounds like. So it looks for supernovas. It's a 0.5 meter telescope on the mountaintop. And then there's another telescope that I didn't point out in the mountaintop called the Global Oscillation Network Group. It's just a 2.5 centimeter, so it's a pretty small telescope. It's a solar telescope, and it's part of 6 stations that are around the world that are observing the dynamics of the sun, structure of the sun. Another telescope that was down near the Tenet telescopes was University of Wisconsin H Alpha Mapper, or WAM telescope. It's a 0.6 meter telescope run by the University of Wisconsin, and it studies the distribution and kinematics of diffused ionized gas in the Milky Way. And then there's one other telescope kind of off to the side here. This is the Korea Microlensing Telescope. There's 3 of these, one in South Africa, one in Australia, 1.6 meter telescope that discovers extrasolar planets based on the analysis of gravitational microlensing. So that's being used. Okay, so that's the Tenet telescopes. So that kind of concludes our tour of CTIO. Are there any questions at this point?
I don't see any new questions in the chat. Does anybody have any questions on this part? I don't see anything.
Okay, then
Back
we'll
to you.
continue on, because our next stop is ALMA, which is the Atacama Large Millimeter Submillimeter Array. So we left CTIO, we went back to La Serena, we took a flight back to Santiago, changed planes, and then flew up to Calama. That was a very short layover, and unfortunately, not all of the luggage made it, including yours truly. So we got up to Calama, and I didn't have my luggage, my checked luggage with me, but I had prepared for that, so I was okay. And then from there, we rented 3 pickup trucks and drove a caravan up to ALMA, the ALMA Operational Air Support Facility, which is located right here. The telescope array, the antenna array, if you would, is actually 28 miles from that up here at the array site. And we'll talk about both of those. On the way, we passed through San Pedro de Atacama. We'll talk about that because we wound up staying there for a couple of nights later on. But we stayed overnight, 2 nights at ALMA. So it took us all day to travel from the Cerro Tololo and take the 2 flights and then drive up to ALMA. That was basically all day. That's all we did. The support facility is at 10,000 feet. okay, about 3,000 meters. And then the array itself is at 16,500 feet. So we'll get to that. The Atacama Large Millimeter submillimeter array. It's a international partnership of 3 organizations: the National Science Foundation, the National Institutes of Science and Natural Sciences in Japan, and then the European Southern Observatory. They do collaborate with the National Science Council of Canada, with the Ministry of Science in Taiwan, and the Korean Astronomy and Space Institute as well. And of course, they are all doing that in cooperation with the Republic of Chile. So the operational support facility is here. There's basically everything in support of the telescopes and the operation of the telescopes, of the dishes themselves, with the exception of the computer center, is located here. So the residence halls, the cafeteria, the maintenance facilities, all of that are located here. That's me. My luggage arrived at noon the next day. I had an Apple AirTag in my luggage, so I was able to track this thing even when it was Santiago. When it got to Calama, I knew exactly where my bag was, and the folks who were with me were pretty impressed by the fact that I knew where my bag was, even though it wasn't with me. And then it finally arrived, and so it was just noon the next day, so it really wasn't too bad. I only had one night without my luggage. You can see these facilities here and here are very nice. The European Southern Observatory built the facilities. They're as nice as any hotel room, and the cafeteria was wonderful, and the food was great too. This is the ALMA control room. They control the antennas here. We're going to see that there are a total of 66 antennas that are controlled. They are connected to the control center that's at the actual array site, as well as with their offices down in Santiago. So there's also an ALMA office control room down there in Santiago. The ALMA antennas, so they're built by 3 different manufacturers, one in North America, one in East Asia, and one in Europe. There are 4 different types of antennas, different styles. Okay, all 3 of these large ones are 12-meter antennas, and this is a 7-meter antenna. Okay, they all have extremely precise surfaces, down to about 1/4 of the width of a human hair, which is pretty impressive for a large dish. Each of them weighs about 100 tons, and that's pretty impressive because they can be moved around. We'll talk about that. Here we are next to one of the antennas that happened to be at the operations facility. Again, kind of a castle green design, because the radio waves will reflect off the dish and then come to the center and then are reflected back through the hole. And behind the hole is the detector. I'll talk about that in a minute. And that's all of us there at the operation facility. This is the electronics lab that's in the operations facility. This is one of the detectors that would be behind the dish there. And in there are 10 different detectors at and each one at a different frequency. As this is one of them that's on the bench. Oops, sorry about that. This is one of them that's on the bench here. This blue area is where the detectors are actually are, and it's arranged such that when the radio frequency comes through, it will go to all of the detectors simultaneously. So all the detectors are detecting radio waves at the same time and passing their signal on. This blue area is cryogenically cooled with liquid helium to minus 452 degrees Fahrenheit, 4 Kelvin for you astro geeks. And then the signals are routed through the gray box and out to the ground, to the array operations center, which I'll show you in a little bit. So ALMA measures the continuum emission of cold interstellar dust. It has an amazing resolution to it, and we can see how this is a Hubble, and this is Herschel, and this is what ALMA shows. It's so much more detail. This picture over here is a protoplanetary system being formed around a star, and the resolution is really quite amazing from the ALMA telescope. So I mentioned they can move these telescopes around, and to do that, they have two specially designed forklifts. One's called Otto, the other is called Lori. They weigh 150 tons, and they're designed to lift the 100-ton antennas. They actually just pull around the antenna, and then there are a couple of plates here that this device gets up underneath. All of the wheels that we saw there, excuse me, here, all of these wheels are hydraulically and pneumatically controlled so that they can kind of go up and down a little bit. They have millimeter control. I mean, that's how precise they are. And they get up underneath the telescope, and then you use the inclined plane to lift the telescope up and center it onto the machine. So when they move the dishes, I told you they were cryogenically cooled, right? So they don't want to turn that off because then they got to recool down the antenna. So they actually switch the power from the ground to this device right here. It's a generator, so that they can keep the antenna active and cryogenically cooled while they're moving it. And then when they get to the other end, they reconnect it to the ground, and so that way they never lose the cryogenic cooling of the antennas while they're moving them. Okay, this is the cab that's in the front of the thing, and then they can also control the machine from a control box from outside of it. Okay, I got this here. This is at probably about 2x speed, and this. So this shows it moving the antenna from the operational support facility and getting on the road up to the array site. And so, like I said, this is sped up, so it's not going that fast. It goes at about I think 3 to 5 miles per hour is all the faster that it goes, and it takes it up there. But this is also what they use, and they have, like I said, a twin of that unit up on the array site that they can use to move the antennas from one pad to another.
Hey, Dave, can I ask a question? Can you hear me?
Okay. So this is the
Just a quick question. What is the advantage of having a radio telescopes at high altitude? Is it particular?
I'm gonna talk about that.
Excellent.
Okay. All right. So the array site is up here. It's located on what's called the Chanator Plateau at 5,000 meters or 16,500 feet. Okay. And they can spread them out. And thanks for the segue there, Suresh. So when we talk about radio waves, as they go through the atmosphere, the molecules in the atmosphere, and particularly the humidity and the like, all attenuate or reduce the signal strength of radio waves coming through. So here we see this is the throughput. So the higher you are here, the more signal that's coming through. And you can see at various frequencies that the atmosphere tends to cut down how much of the signal is able to come through at radio frequencies. Now this is at 2,550 meters, which is the Plateau de Boer. Okay, and if we look at the Chanator Plateau, you see we get, because we're at a higher altitude, there's less atmosphere. Plus, it's an extremely dry atmosphere. We get a lot more throughput of radio signals on the Chanator Plateau at 5,000 meters. So that's the advantage. Okay, so this is an aerial shot of the array. We can see that there are antennas out here. They're located all over the place out there, as well as the central core. This one in the middle, this is where the 7-meter and 4 of the 12-meter antennas are, and they call this the what do they call that? That was the I got another shot of it, but it's the compact array. That's what they're called. The compact array, which gives them kind of some depth, and the rest of the antennas help to add to the resolution of it. Again, there's 66 antennas. Okay, so there are 12 7-meter antennas, and then there's 4 4 12-meter antennas associated with the central core, and then the remainder of the 50, I think it's 54 antennas are spread out. Okay, so by being able to spread out all of the antennas, what you essentially have is one huge giant radio antenna, as large as 16 kilometers in diameter when they get them all spread out, which gives you some amazing resolution. Excuse me. So what they do is that what makes all this possible is something called radio wave interferometry. And so what they can do is they can take a signal coming in into 2 different antennas, okay, and then these antennas are a certain distance apart. They take these and they can combine the signals and synchronize them, and they do that all electronically. And then it makes it look as if the antenna is the size of D here. And they do this with all of those antennas, and they have a huge computer center up there that they do that in. So we were allowed to go up there if you could pass the physical. And the physical consisted of a blood oxygen level. They checked your pulse and they checked your blood pressure. There were 3 of us, yours included, who failed to pass the blood pressure test. And so I was not able to go to the high site, unfortunately, but a lot of my comrades were. And so they went up to the high site. These are all oxygen tanks on their back, and they have little tubes going to their noses so they can breathe some oxygen. And they got to go up to the high site for about 2 hours. And they were kind enough to share their photos with me. So here they are up there. This is the guy who was our tour guide for ALMA, and he showed us all around the facility and stuff. He was great. This is the compact array that I mentioned up there. Okay, and so here's the data center. So all of those signals from all of those antennas come into this data center where they are combined and correlated, and the image is then produced and sent on to the user. It's called a correlator and signal transmission center, and it's one of the fastest supercomputing centers in the world. And the system has just received approval for a 2-stage upgrade that will increase its data production by 200% initially, and then by 400% ultimately. And this will add more than 1,000 hours of observing time each year by doing that. This can tell you the power of ALMA. And this is the EHT was the Event Horizon Telescope, and this is the one where it photographed the black hole at the center of M87. But this shows you, this is the image that was actually published. That's great. However, without ALMA, it would have looked like that. So the ALMA telescope provides a kind of resolution that you just can't get with other radio telescopes. Okay.
We got
Yes.
2 questions. Can
Okay.
I jump in here?
Yep.
So Michelle asked, when they move those dishes around, do they move just for servicing, or are there other reasons they'd want to move those scopes around?
No, they could reconfigure them if the science that they're interested in doing requires them to move the telescopes. However, to be honest with you, I think that most of the time they stay pretty much in the location that they're set to.
Okay. And the second question is Kevin Pierce asked, what's the threshold for high blood pressure when they did the test for you?
Well,
Is it like 200?
No, much lower than that. The threshold I think was around 140 or so, and I was up to 160. I actually went to the doctor when I got back because I need to have my blood pressure worked on. So,
So there you go. So you went 8,000 miles away to
find out I needed to go to the doctor, right? Exactly.
That's all we got. Go ahead.
Okay. So we stayed at ALMA that night, and the next day we went and flew back to Santiago. This is the hotel that we stayed in Santiago, both when we came and when we came back. Very nice hotel. And then we got back later in the afternoon, went to dinner that night, and then the following day we went and I should actually let me rephrase that. That's not how it went. When we left ALMA the next day, we actually went to San Pedro de Atacama, and San Pedro de Atacama is that small town there, and we did spend 2 nights and a full day there. And the full day was used to do some shopping, some tourism stuff, and we also visited in the evening. One evening we visited a nature preserve, and then the next day when we did the tour of the San Pedro in the afternoon, we went out to a very unusual nature preserve where there were flamingos, and I could talk about that at the end if people want to stick around. Visiting Santiago offices. So we went there, and the next morning, this is the final morning. I was leaving this evening. We visited the Santiago offices of the European Southern Observatory and ALMA, and so the ALMA office down there. The ESO, besides ALMA, they have 3 other sites in Chile that are observatory sites. La Silla is one of them. Cerro Pachón is another one, which is where the very large telescope is. And then they're building the extremely large telescope at Cerro Amazonas. And this is going to be a 39-meter telescope having 798 different mirror segments in it, and a 5-mirror design. And the field of view is going to be 10 arc minutes. This is going to be quite the telescope when they get done with it. First light in 2027. This is a model of it that they had in their office. So it looks like quite the telescope. That evening I left to return home to Minnesota. It was an 11-day trip of a lifetime, and I gained 10 new friends. It was 88 degrees in Santiago when I left, and it was -2 degrees in Minneapolis when I arrived. So that's basically it. Now I do have a few more slides talking about some of the other things that I did, but let's stop, and people can ask questions.
Okay. If anybody has any questions, feel free to unmute and ask Dave directly. Anybody? Any questions out there?
Hey, Dave.
Dave, say again the altitude that the upper telescopes were on that you did.
The high site, yeah, the high site was at 5,000 meters, which is 16,500 feet.
And it's just one telescope up there.
But in ALMA, no, it's a plateau. So they had the whole array on that
Okay.
plateau. That whole
There's
plateau.
about 30 dishes. There's about 30 dishes up there, you said, right?
No, 66 dishes up there. 66 dishes up there on the plateau. It's like a plane, a high altitude plane out there, all at 16,500 feet.
Trina had a question. Trina?
Yeah, I knew Dave wanted to add a little bit more, but what are the requirements for doing something like this or submitting applications? I mean, is it intensive or just general thing, or what's the background that's needed?
Dave, I think Trina wants to go.
So
I wouldn't
there's
mind.
So every fall they post the application form on their site, and they want to know what kind of outreach you do, what kind of audiences you've spoken to. They want to know why you want to go down there. They want to know what you hope to get out of it, what you'd like to be able to share with people. There's a number of questions that are in the application. The application, I think, it's several pages. So,
Dave, all these sites that you've shown us, Cerro Tololo, ALMA, all these sites, how far apart are they in, like, as the crow flies?
So Cerro Tololo and Cerro Pachón are only about 10 kilometers apart. They're fairly close to each other. So I can let me see. Let me go back to a map here. The almost quite a bit farther north, closer to the equator. Let me see if I can get to it real quick here. So here's La Serena here, okay? And so Cerro Pachón, Cerro Tololo were probably right about in there, and then ALMA was way up here, so quite a bit apart. If you take a look at a map, ESO has some telescopes in here, and I think there's one up here. And if you take a look at telescopes in Chile, they're all over the place in this northern part. Almost all of them are north of Santiago, because that's where the Atacama Desert is. That's where the great weather is, and all of that.
So for normal blokes like us, if we showed up, doing a tour of Chile or just went down there, can we
Mhm.
visit these sites?
No, you
Because
can't.
like a lot of professional observatories have like standard tour hours during the day.
Yeah, you might be able to get into a tour that would be able to take you up there. I didn't see where there was any kind of standard, walk-in type of thing. But they I'll tell you the reason why is just getting up there is a little hazardous for the optical observatories, because the road up there is kind of windy and treacherous, and it is controlled by the AUI and ARA. I mean, it's gated. I mean, actually gated, so you have to get past the gate to get up there. So you would have to be with a group, I think, in order to get up there. They do have groups that go up and visit, but they're, I'm sure it's arranged ahead of time. ALMA, I'm not real sure whether they have any groups that go into ALMA or not, because again, it's kind of a working facility, and I don't know how much you can really actually see. But the impression that I got was that the general public doesn't have access to those facilities.
And unlike other wavelengths, you could do radio work during the day.
Yes.
So, right. So if people showed
Correct.
up with like their cell phones, that could actually interfere with their observations, right?
They could. Well, yes and no. I mean, it is because they're doing interferometry, they can filter out a lot of that stuff.
If one were able to get on a group to go and see these, what percentage of these sites that you visited would be wheelchair accessible, and what percent involved stairs and other barriers?
Good question. They did have elevators in the larger observatories, so we took elevators up and down. It's very hilly, so I can tell you it wasn't. There was some accessibility, but I don't know if I'd consider them real accessible or not. There are not a lot of steps. I mean, they do try to get down. So, and I don't know how many astronomers up there need ADA type of accessibility, and I don't know what the rules are either. So, I'm trying to think now, and I don't think there's a huge accessibility issue. Some of the older observatories that were up there, because I mentioned some were built in the 70s and late 60s, some of those probably were not as accessible as the newer ones.
Probably more of an elevation concern than it would be.
It's an elevation control concern much more, I would say, for sure. We walked around a little bit at Cerro Tololo, but almost every place else we drove from spot to spot, just because walking around at elevation, it wears you out. Unless you've been at elevation and really walked around, it takes effort sometimes.
Does anybody else have a question for Dave?
Well, I'm going to go, and you're welcome to leave if you want to. I understand this is getting kind of long, but I did want to talk real quick about some of the non-astronomy type stuff that we did that were kind of nice. When I first arrived in Santiago, we did sightseeing that day, and a group of us went to the Sky Casanera, which is the tallest building in South America, 62 stories. And went to the top of that. There was a great 360-degree observation deck up there. We could see all of Santiago and the mountains around Santiago, and so that was pretty cool to go and do that. When we went to La Serena, the evening that we arrived, we went to a touristic observatory. As we arrived at the observatory, this is a view of Cerro Pachón. It was about 12 miles away that we could see up there on the mountaintop. This touristic observatory was a kind of a bed and breakfast that was part of a vineyard, but they did have kind of a geodesic dome type classroom there where they did outreach and talked to us about the outreach that they did. Some of it is tied to the observatory, meaning that people from the observatory would come down and talk about astronomy outreach. But that evening, we were able to do some observing as well. They had a telescope set up, and they had a very nice hors d'oeuvre table set up, and Chilean wine, which again is very good. And we got
What-
to do some observing.
What was the coolest thing you saw, Dave?
Well, the coolest thing I saw was the Tarantula Nebula, but that's you can't see it from here. But here's a shot of the stars here, and this is Orion, right? But it's upside down. Here's the sword pointing up instead of down. So that's what I'm saying about things being a little bit disorienting, and so you had to kind of recoordinate yourselves. Did you find that too, Suresh, when you were down in South Africa?
Yeah, you're bringing back memories. I actually turned around and looked at the sky to get my orientation,
Yeah.
the Northern Hemisphere orientation. I actually physically turned myself around because I was
Right.
so disoriented. I
It
couldn't
is.
figure
It's
things out.
very. I was amazed at how disorienting it was, and so. But after a while, you get used to it. But it was disorienting at first. San Pedro de Atacama. This is a shot of the street there. You know, it's just a little town type of place. We did do some shopping there. They had nice town square. We had breakfast there, and then in the evening we went to this Reserva Elemento Pura Better, and they had some llamas there, so we got to pet the llamas. That was fun. But what they do here is they're actually educating the indigenous peoples about the way life was before the Spaniards came, and so they're reintroducing the native vegetation that was around. They are talking to them about their beliefs about how the sky and the stars and the earth were all kind of one, you know, type of thing, and also some of the farming techniques they had, because this is a desert area, so the water management was very important, and they showed how they did water management and how they did farming back then, because it was all of this was kind of lost when the Spaniards took over and kind of forced things on them. Here's
Okay.
some of
On
the vegetation. Yeah.
Sorry, on that same point, as you got further away from the ocean and saw some of these indigenous areas or former indigenous areas, did you feel a sense of independence from like the coastal areas? Like in Peru, the Inca, the Quechua people want nothing to do with the people on the coast. Did
Oh,
you feel the same thing in Chile?
I didn't feel that, but I didn't really pursue that either. So I don't know if there's that feeling. I didn't get that feeling though. I didn't get the feeling there's that kind of animosity between the two. So we were there in the afternoon, and then in the evening, they too had a kind of a hors d'oeuvre spread with Chilean wine. And then they had a fire pit that we sat around. And then this is a father-son group that he actually handmade instruments that were typical of the indigenous species, the indigenous peoples. And there's a flute and a drum and like this is one of the ambassadors playing a drum, and then they sang some songs and talked about how the music was portrayed as, you know, when a certain queen died, she wound up in the heavens, much like, you know, the Greek and Romans. You know, they too placed important people in the heavens. And the interesting thing about the way that the Chilean indigenous people look at the sky is that they tend to look at the dark spots in the sky rather than the stars. And they would take the dark spots and see animals and creatures and people from the dark areas of the sky as opposed to the lighter areas. And then this is the National Reserve for La Flamingos. So when I think of flamingos, I think of the pink flamingos down in Florida, tropical thing, right? Well, here we are. We're out. This is in the middle of the desert. It's actually the salt flats of the Atacama. All this white is salt. And in the middle of this is the Chaxa Lagoon. And it's a very shallow lake out there. And these flamingos thrive out there. And because the lake is shallow and there's a lot of nutrients, microorganisms and very small shellfish.
Why is that in Minnesota?
Say again. Anyway,
Jim, I think you're on speaker.
So they feed on these and they thrive. And there's actually this is at 2,300 meters, which is about 7,500 feet, and it's hot during the day. It was really pretty hot. It gets pretty cool at night because it's a desert area. But these flamingos, they flourish there, and it was just wild to see this out here in the middle of the desert.
So they can thrive on like salt water? essentially?
Yeah, yeah, salt water and the crustaceans in the water. It's the
Crazy.
wildest thing, man. It was crazy. That's it for me.
I wonder,
Anybody-
Dave, I wonder if this area up here in this reserve was formerly under the ocean, essentially?
That's a
Got
good question.
uplifted?
I don't know. I think that that's very possible. Of course, this is a very volcanic area. There are over 40 volcanoes in Chile. 3 were erupting while we were there, but they weren't anywhere near us, so we didn't see them. And of course, you get a lot of earthquakes. But it's an area that very very easily could have been underwater at some point and was heaved up. I think that what the flamingos are feeding on, though, is just stuff that grows there because it's the salt and the water is very high in nutrients, and so the microorganisms and shellfish grow relatively quickly there, so they're able to feed on that.
This is
David
Paul.
asked,
Yeah,
go ahead,
Tom?
Paul. Go ahead, Paul.
Paul.
Yeah, did you see any wildlife at the higher elevations up by the telescopes, like small lizards or?
Llamas.
No, saw mules. There's burros, wild burros, all over the place, and smaller versions of llamas called the vicuñas. We saw them at the higher elevations as well. I didn't. There are probably some lizards up there. I didn't actually see any, but we did see the burros and we saw the vicuñas.
David asked, did any insects bother you?
No. Well, that's not true. But for the most part, not. Although when I was observing one night, I was sitting in a chair and I was trying to use binoculars, and there were some mosquitoes there. And that was at CTIO at 7,500 feet.
Wow, even at
Yeah.
that elevation, you get
Even
mosquitoes.
at that
there?
elevation,
Wow,
yeah, there were some mosquitoes, but
crazy.
for the most part, that was about it.